Hey everyone, hello. So I don't know at what time you're watching, so just greeting from my side. So my name is Manisha, and it's been almost 3 years or 2.5 years that I have not made any kind of educational videos. So if you look for my past videos, you will find them mostly for the lower grades, right? Because that was the need of that time. So now my focus, why I have planned to create these videos, because I really want students to get rid of the maths phobia, especially when I talk about grade 10. Yeah, so grade 10 everybody's like, अरे board का exam है, board का exam है, so it has to be whole and soul dedicated to study. Of course I agree, you have to work really very hard when it is grade 10, right? It's not only from the NCRT, but you need to go through all the possible reference books, and so that's where I'm gonna help you. So I have actually searched a lot of questions, have seen the pattern of how the questions are asked in CBSE question papers, and that's how I made a list of the questions. Not actually made a list, I will be working on it. Yeah. So for today, I'm gonna take a topic. You know the topic already. I don't have to introduce topic with a boom. So yes, this is a topic, quadratic formula, and basically the quadratic equation. So when we talk about the quadratic equation, now in quadratic equation, if you check for the NCRT, so they have the linear equations in two variables, and they also have this quadratic equation chapter, right? So what type of questions can be asked? So whenever we are talking about the quadratic equations, so they can possibly ask you for the values of x, right? Simple. This is a very basic question. They will give you a they will give you a quadratic equation where you need to find the value of x. You know, simple. But sometimes the questions are not that simple. Why would anybody you will give you the questions which are too simple to understand, right? So questions, sometimes we have to frame the equations and solve it to get the value of desired variable. Now what is the desired variable here? Of course I'm talking about the x, because it's like in our mind. So whenever we are talking about a variable, the very first thing that comes to our mind is x, right? So x, y, these are the variables. So let's start, and yes, I hope this session gonna be helpful for you. I'm going to be very it will be a very normal speed. I'm not going to be very fast because I really want all of you to understand. So let's start. Yeah. All right. So now if I show you this page, you can see here I have a good set of questions, right? All right. Now I'll tell you about all these questions one by one. So I'm not gonna cover everything in this video for sure. That's not gonna possible because I'm planning to solve each and every question, right? And that cannot be done in a single video. So what we can do here is we can just see or have a look at the types of questions. So here most like all the questions that you will be seeing here will be on word problems. Okay. So for example, one type of question is where you have to add the digits and you get this number, right? For example, the sum of two numbers, the difference of two numbers, the question number 1 and 2 itself. See the question number 3, the difference of two numbers is 8, right? And the sum of the squares of these two numbers are 320. So such type of questions also comes in the NCRT or CBSE paper, right? So question number 6, 7, 8 are on that. Now question number 9 is actually based on the age, which is again a very important part of quadratic equations. So if you ponder the last few question papers of CBSE, you will see that age related questions are seen really good in number, right? So it's very important to have a good practice of age related word problems. Now coming to the next, if you see question number 13 is not based on the age but based on the distance, time, speed. upstream, downstream, all such questions also come in the exams, right? So these are the three main possible type of questions which you may experience in your board exam. Okay, so question number 12 is also like downstream, upstream. Question number 15, if you say, it is totally based on the time traveled by a train and visiting grandmother, cyclist, going. So basically all these questions covers the time and the distance concept. Yeah, but it has to be solved using the quadratic equation, right? Okay, so 23 onwards, if you see, it's based on a shape like rectangle, square. So based on the area, length, width. So we have to assume one side to be x and the other side to be this. Yeah, don't worry, we were gonna discuss it. And yeah, so till 30 I have discussed all the types of question. I'm discussing about the types of question that you're gonna experience in your exam. Now next, can anybody guess? Yes, this is a case-based question, right? Of course, case-based question is very important. You know that in a CBSE question paper pattern, there are special 12 marks for the case-based questions, right? So we can have one question possibly from this part also, like quadratic equation also. The chances are like 50%, but still for our side, we're gonna have at least 2 questions on case based, and these 2 case based questions I have taken from the CBSE sites itself. Alright, so either this question or a similar question you may experience in your exam, not beyond this. Okay, good. So let's start. Okay, let's start with question number 13. Because it is based on distance and time. Alright. So it's not like distance and time is my favorite, but I know this is somewhere which, like, you know, we feel like, okay, this is not that an easy topic or not an easy question, but let's experience this. Okay. So whatever is challenging for us, let's try to solve that first. So I'm just creating some space in between. Yeah. All right. So what's the question? Let's understand the question and try to solve it. So you can see that there is given some distance, and on the way back, due to the road construction, he had to drive 10 kilometers per hour slower, which resulted in the return trip taking 2 hours longer. See, it is like in most of the time and distance related question, you will see that either distance is same, okay, or the time relation is given, these type of questions. Now, look at the last sentence. How fast did he drive on the way to the conference? How fast means they are talking about the speed. So it's a very key formula here, that whatever they ask you at the end, no, assume that to be variable. Yes. So let us say that the fast, or how fast means the speed of the person is x. Right. So what we can do here is we can assume that the speed is equals to x kilometer per hour. Now what is given? That the resulted return trip taking 2 hours longer. So I know there gonna be 2 times, right? 2 times. What? On the way to the conference, right? And on the way to the conference and returning. So it's like normal going and returning. Now what will be constant over here? The distance will be constant. Correct, 120 kilometers. Right? So we're going to have 2 types of time here. On the way back, due to the road construction, he had to drive this. Right? So first will be when he is, first case will be this and this. Now, okay, let's say take the normal case. Alright. So when normal case is there, so the time for the normal case will be the distance upon speed. Correct? Yes, 120 upon x. Now he went to the conference with the speed x and it took tr time. I'm just taking tr, you can mark anything. I'm just taking it as tr. Alright. Now what about the time required or like for returning or on the way back? So due to the road construction, he had to drive slower. So when he's driving slower, but he's driving slower by 10 kilometers per hour. So this time the speed will be x minus 10. Right? But will there be any change in the distance? No. The distance will remain same. Right? But did you notice one thing? See, if I'm taking x time, then I'm going to take, if I'm, driving with x kilometer per hour speed, then the time is tr. And if I'm driving with x minus 10, like slower, then time will be more, right? So can I say that tb over here is greater than tr? Yeah. tb, that is the time taken to return, will be more or greater than the tr. Correct? Alright, now this is a very important point because here if you read the question, the difference in the time is also given. Now what is the difference? The difference in these two times will be 2r because that's what they have said, right? That return trip, it will take 2 hours longer. So means whatever the time was there to reach to that point, and in returning, of course, it's taking long time, right? So the difference is this. Now let's actually substitute the values. And try to solve it. So this, now from here, it's all your part, okay? I can help you in framing the equation, but solving the equation will be your part, though I will be doing it, but still. Okay, because solving the equation is somewhere students make the mistake. Yeah, most of the students, they make mistake. So what I can do here is, just to make it easy, I can take 120 common, right? And it will be 1 upon x minus 10 minus 1 upon x is equals to 2. Just a second, I need to check. Yeah, okay. Hold on. Okay, so here it is actually equals to 2. I know you won't be able to see that because it actually went outside the frame. Yeah. Okay. So I'll just create more space over here. Okay, let's continue this. So 120 and x. Okay, now what I'm doing is, for this part, I'm going to take the LCM. Yeah, I'm going to solve this bracket, of course, by taking the LCM. And how can I do that? X minus x plus 10. Any doubt over here? If yes, then I'm going to put the bracket and now it will be even more clear to you. This is how we take the LCM, right? Or how we solve something which is there in the bracket. Correct? So that's what we are doing. Now if you solve it further, you're going to get minus x and positive 10. Remember, it is very, very important to put the brackets. Okay, let's solve it further. I can see these two can be cancelled and I'm left with x. In the denominator, you will have x square minus 10x is equals to 2. Now if you take it to the right side, alright, of course you can take this 120 to the right side, because 120 is getting multiplied with whatever is there in the bracket, right? So if you transpose it to the right side, it will be divided. So generally students, they get confused if they should take 120 to the right side or not. But yes, here you can, because you have taken it common and then you are transposing it. So let's simplify it. So it will be x square, like I can do the cross over here, x square minus 10x is equals to 600, or I can transpose it to the left side and it will become this. Correct? Okay, now the question comes, how can we possibly solve it? So I feel I can take the product as negative 600 and I can take the sum as negative 10. So what we can do is, I know that 600, especially the 6 I can get when I have 3 and 2, right? So if I take 30 and 20, can we get 600 upon multiplication and 10 anyhow by addition or subtraction? Yes, we can. So that's our answer. So x square, yeah. Now negative 10. Negative 10 means negative 30x, positive 20x, negative 600. Okay, how did we get this? Because the product is negative, doesn't matter, any of the number can be negative. Sum is negative. Now sum is negative, it means that the bigger number has to be, the greater number has to be negative, right? With a negative sign. That's why negative 30. Let's solve it further. So x square. Okay, so I can take x common and it will be x minus 30 plus 20 common and it will be x minus 30 again. Got it? And this is equals to 0, of course. So x minus 30, x plus 20 equals to 0. So x will be 30 or x can be negative 20. Alright, read the question again, see what they have asked for and take that. Of course, I cannot take x as negative 20, so x will be 30. I hope it's clear. Yes. See, there are two main things. First, read the question well and frame the equation. That's the reason I'm not only taking one question today. I'm going to take more questions. Alright, similar questions so that you get a good practice. And let's see what's the next question is. So once you get the equation, please be very careful in the calculation part. Okay, so I'm gonna insert some space. Alright, now let's see the question. So now Mark rows downstream for 30 kilometers and then around and returned to his original location, and the total trip took around 8 hours. If the current flows at 2 km per hour, how fast Mark would row in still water? Now this is a very important and interesting question because it is actually based on the upstream and the downstream. Yes, so Mark rows 30 km downstream, and of course for the upstream also the distance will be same, correct? So distance will remain 30 km for sure. Then around and return to his original location. Okay, so distance is 30 km downstream and returns. So the total distance will be 60, but I'm just taking 30 for now. Okay, because I'm taking two cases, upstream and downstream. Okay, then original location. The total trip takes 8 hours. So what I can say is, he might have taken some time for the upstream and might have taken some time for the downstream. But the total time that he actually took for both sides is 8, right? Now if the current flows 2 km per hour, okay, so how fast Mark row in still water? So let the speed of Mark in still water is x kilometers per hour. Okay, now just a second, let me check if it is not getting out of the screen. No. Okay, so the speed, we are very sure it is x kilometer. Now the current flows. So when we are talking about upstream, it is very important to understand that what happens in the upstream. Yes, so when it is upstream, the distance or the speed will become low, right? The speed will be less as compared to downstream, right? So what is the meaning of upstream? Upstream means going against the current and downstream means going along the current. right? So when you're going along the current, of course the speed will be added. When you're going against it, your speed will be less. So for upstream, the speed will be speed minus this, the speed of the current, because you're going against it, right? And for the downstream, let me write it here. And for the downstream, the speed will be x plus 2. What? Kilometers per hour. Yes, this is very important to mention. Otherwise, you never know for what reason the teacher is deducting the marks. Okay. As we know that time is equals to distance upon speed. You know distance, you know speed. Let's go for it. So the time for the upstream will be what? Correct. Distance, that is 30, upon speed of the upstream. The time for the downstream will be 30 upon x plus 2, right? Which is equals to the total time, which is 8 hours. Alright. I don't feel like solving it now because I really want you to do it. So please pause the video and try to solve it. But for the safer side, I'm also gonna do it, okay? 30, I can take it as x minus 2 plus 1 upon x plus 2 equals to 8. Now, very easy. Let's solve whatever is there within the bracket. So it will be x plus 2 plus x minus 2 upon x minus 2 and x plus 2. Okay, you can see a smile on my face now. The reason is what most of the students they do is they start solving it. Yes, so please don't do that. When the question is really simple, please don't make it complicated. Look if we can use any identity over here. Yes, we can, right? A minus b and a plus b can be used, right? Okay, let's have a look at the numerator. Is there anything that we can cancel? Yeah, we can cancel this. Correct? So it will be 2x upon x square minus 4. 30 is equals to 8. Now I'm gonna do it on the right side. Okay, so it will be like 2x upon x square minus 4 is equals to 8 upon 30, or 2 4s are 8, 15 and this. Correct? Alright, let's simplify it further and it will be, let's do the cross over here. So it will be 4x square minus okay, x square minus, yeah, it's correct. Alright, I was just checking if I have done anything wrong, is equals to 30x. Cool. So okay, I got this. Now what can be done here? Of course, we can solve it further and get our answer. Can we try to do that? Yes? Okay. Alright. So now you can solve from here by your own and get the value of x. Okay. Now solving may include, see, you can take 2 common from here and go for the product or sum, or you can also use the discriminant. Yeah. So if you don't remember what is a discriminant, let me show you. So this is the formula that we use for the discriminant. Alright. So the b square minus 4ac is what we call as the discriminant. So first you calculate that, and once you get that, you put in this formula and you get the value of x. Correct? Alright. Now let's have a look at the next question. So for most of the question, what I'm gonna do now is I'm gonna just frame the equation and solve it, just leave it like that so that you also do something. Okay, so kind of a homework. Alright, I'm just gonna help you in framing the equations, but yeah, if I feel like okay, there is any question where you may face problem, then I'm gonna solve it for you. Alright, let's read the next question. A train traveled 240 kilometers at a certain speed. Okay, when the engine was replaced. Okay, these questions are really amazing. Okay, you're gonna see these questions for sure in your exam. So what is there? Actually, because of some reason, the time either increases or decreases. We have to understand the reason and then we have to compare the time. Alright? So most of the questions are based on this. So look at the question, and whenever we are reading something, let's note down all the pointers that are given. So for this question, I can see that the distance is given to us. The distance is 240 kilometers. Okay, now when the engine was replaced by an improved model, so there will be no change in the distance for sure, right? But the speed was increased. But do we know what was the speed earlier? Or see, look at the question. What was the rate of change of each engine, right? So we need to understand that what is actually the change in the speed, right? So let's say before the engine was replaced, the speed was x, all right? Before the replacement. So I can say t before and t after. TR means replacement. Okay, and B means before. I'm just taking it as this. You can take it like the way you want, but there has to be two cases. One before the replacement of the engine and second one after the replacement. Right. So before the replacement or after the replacement, the distance will remain the same. See, 240. There is only change in the speed. So first, if the speed was x kilometers, so I should write over here, I'm so sorry, let the speed of train before replacing engine be x. Okay, x kilometer per hour. So we are taking x kilometer per hour. Alright. Now, after replacement, what happened if the speed is increased by 20 kilometers? So speed is increased by 20. So which one you think gonna take more time? A train with more speed or train with less speed? Less speed, right? So I can say from these two things that, just a second. Yeah, so I can say that the TB is gonna be greater than TR. So if I'm actually looking for a difference, I need to make sure that I'm subtracting a smaller number from a bigger number. That's why I always check that which time is greater. Alright, if you do like TR minus TB, then sorry, but you will land on a totally different answer. Okay, so be very careful, check for the time which is greater and then solve it. So TB minus TR will be 1. Like it's given as 1, right? For the time travel decreased by 1. So it is decreased means difference is 1. Now what should we do next? Absolutely. So here we go. 240 upon x minus 240 upon x plus 20. So if you want, I can solve it, but I feel like you should have a practice of solving. But I can guide you. So the first step will be take 240 common and transpose it to the right side. So it will become 1 upon x minus 1 upon x plus 20 is equals to 1 upon 240. Alright, solve it further. It seems like I'm going to solve it only. Okay, no worries. Okay, you pause the video and you just do it by your own. Please don't copy what I am doing. And just be careful what you are doing, okay? If such question comes for 5 marks and just because of some silly mistakes like mistake in the sign, mistake in copying down the numbers even, can lead to really very bad marks here. So if you know the concept, please be extra attentive then. Make sure you're not losing marks for what you already know. Okay. So I can just cut this and it will be 20 upon x square plus 20x 1 upon 240. Okay, that's it. I'm not gonna do it more. Now you do it. X square plus 20x. You know what I'm doing, right? I'm doing the cross of it. So it will be, sorry, equals to 4, 8 and 0, 0. Solve it, transpose it to the left side and get your answer. So I think I can help you with just the number. So just don't take these two zeros and take these only. So 6 8s are 48 and okay, let me check. So if I, yeah, 6 8s are 48 and I can take 0 0 and I can actually have 60 and 80 as a difference to be 20, right? 20 I can have as a difference of 60 and 80. So I can write as I want positive 20. So positive 80 and negative 60. So you can use these two numbers. Yeah. Alright. So we are done with this. And once you get the value of x, you... yeah, that's what all they have asked for. Alright. Okay. Now I need time so that I can put some space. By the time, please read the question. Or you can actually pause the video and, you know, try to solve it by your own. Okay. Now it's about Mr. Johns who is visiting, who visits his grandmother who lives 100 kilometers away on a regular basis. And recently there is a new free way that is opened, and although the freeway route is 120 kilometer, he can drive 20 kilometer per hour faster on average and takes 30 minutes less and makes a trip. Okay, so this time let's think of the two cases again. Always make cases that will help you to understand the question. So first is when he's visiting and the distance is 100. And the second case is, it's like regular. See, they have written the regular. So I'm taking it as time required for regular, because I can see again they have compared the time for the two cases, right? So I'm also going to compare the time. So time on regular basis and time when there is a new freeway, right? So I'm going to calculate the time, but here we have to make sure that we are taking the actual distance. Now, see, this is a good question. Why? Because see, if the distance increases, then the time will also increase, right? But if you read the question, the time is decreasing. Why so? Because the speed is also increasing. So I will read the question again. Mr. John visits his grandmother who lives 100 kilometers away on a regular basis. Recently, a new freeway has opened up, and although the freeway route is 120 kilometer and he can drive 20 kilometer per hour faster on average. Okay, so let's say he used to drive with the speed of x kilometers per hour, and now on a freeway he can of course pick more speed and it will be x plus 20. I'm telling you kids, it really helps when you are making the different cases. It really helps you to understand the question. So now the time for this will be 100 upon, now you're getting what to do, right? I don't think I need to solve it. Did I just write s over here? I'm sorry, it should be x. Okay, now read the question. Very important. I know still you can make mistake over here, but you are thinking, okay? See, I agree that here the time is more than on the left side. So according to this, TF should be less than TR. If the speed is more, then the time taken will be less, right? Okay, look here, the distance also. Yeah, the distance is also changing. So time is now not the only factor. But read the question well. So when he is using the freeway, still he can manage to reach 30 minutes faster, or it takes 30 minutes less to make the trip. So obviously if TF is 30 minutes less, it means TR is greater than TF. We got the comparison. Now we can subtract. So it will be like this minus this. So what is the difference in the time? 30 minutes. Do you think it is correct? No. Because they have given in minutes, but we are playing in hours. So we have to, get this in hours only. So TR minus TF is gonna be 30 upon 60, and let's solve it further, and it will be 100 upon X minus 120 upon X plus 20. Do you notice one thing over here? That whenever I'm having such kind of number, I'm always keeping it in a bracket. You know why? Because from my experience. Because when I have experience when I was a kid, and when I used to miss this bracket, then I always used to get a wrong answer, right? So I realized that no, it has every step you should do very carefully, even if it's a bracket. Yes. Okay, now what should we do next? Correct. We can take something common, and what we can take common here? Let me think. Can we take common 20 over here? Right? I can think of 10, but I can further see that both the numbers will be divisible by 2. I can take 20 common. Let me go to this side, and it will be 20 common. So it will be 5 upon X minus 6 upon X plus 20 is equals to 1 upon 2. Now transpose, right? So 5 times X plus 20 minus 6 times X upon X plus 20 is gonna give you 1 upon 2, 1 upon 20. Don't forget this 20, okay, because this 20 is gonna shift to the right side. Okay, why I feel like I have done something wrong? No, it's correct. Actually, we got 20 here and we got 20 here. So I thought I did something wrong, but no, it's correct. Yeah, correct. All right. Solve it. You can pause the video, please, and do it by your own. Every time I think I'm not gonna do the next question, but I don't know why I start solving it. Maybe because I can't see any incomplete question. Minus 1x plus 100, okay, times it by 40 is equals to x square plus 20x. Okay, so it's gonna be minus 40 and plus 4000. So x square plus 20x. If you transpose this minus 40x to the other side, it will be positive 40x. And if you transpose this negative number, it will be a positive number. So you have this. All right. Yes, so that's what we got, x square plus 60x. It should be minus or plus if I have not done anything wrong over here. Let me cross check. Sorry, yeah, it should be minus, no? Yes. Correct, it should be minus. Now you can solve this, and you need product as 4000 and sum as 60. So what can possibly, you can take 140. Yeah, 140 you can take, right? So can solve it then. Ready for the next? Okay, read the question, please. Alright. Now, if a cyclist had traveled 5 kilometers per hour faster, she would have needed 1.5 hour less time to travel. Okay, so let's again divide this in two cases. First, the normal time, and second, time with extra speed. Alright, or the fast time. So it is like normal speed will be, sorry, normal time taken will be 150 upon x, right, where x is the speed of the cyclist, right? So this is the normal for her, that is 150 upon x. Second case is, let's say the speed is 5 kilometers more, so it should be x plus 5, and the distance over here will remain the same, but what about the time? The difference in the time is 1.5 hour. Now, in which case do you think time will be more? Time taken will be more. In the first case, right? Because in the second case, when you are increasing the speed, the time should be less. So I can say here that yes, Tn is greater than T of f. That is, time in the normal condition is of course more than the time in the fast condition, right? In the faster case, I would say. So once you know this, of course, we also know that the difference in the time is 1.5 hour, which I can write as 15 upon 10. Yeah, let me write 1.5 only for now. I'm gonna solve it further. Okay, so 150 upon x. I don't think, I'm seriously not gonna solve it this time. Okay, I'm gonna resist myself from solving. So take 150 common, solve the bracket, transpose 150 to the right, frame the equation, solve the equation. Okay, alright. So I hope you're getting it. See, what's more important over here is that you must experience all types of question. That's my purpose. Okay, must experience all type of questions. So you should not be like in the exam like, oh, I never experienced this question, I don't know how to even start this question. That mind should not what you carry in your exam. Okay, so don't carry that kind of brain which has even no idea about the question or how to start a question. Okay, now by going 15 kilometer per hour faster, a transit bus would have required 1 hour less to travel. What is the average speed? So very easy. Let the average speed be x. See? Now again there are two conditions. Time with normal speed and time with extra speed, or I can say fast speed. Alright. So the time taken with the normal speed will be, distance will be same. So distance, this automatic pen, no? Okay. Distance upon speed, that is x, right? I'm taking this as x, right? And for the fast, it will be, distance will be same, but speed will be 15 plus x or x plus 15. Cool. And yes, of course, Tn is gonna be greater than Tf. So the difference you can write as Tn minus Tf as 1. This is the easiest way you can solve such question. But make sure you're writing the statement. Alright, writing the statement is equally important. Like what kind of statement I'm talking about? Write the statement like, okay, let the average speed of the bus is x kilometer per hour, the time taken will be the distance upon speed, this is the distance, this is the speed, you know, that way. So make sure you're segregating these two cases, case 1 and case 2. Okay, next let's substitute the value and solve it. One more small lecture. It's totally up to you if you want to make a question complicated or easy. If you follow the question word by word and frame the equation accordingly, it will become easy, okay? Sometimes I understand, okay, the questions are complicated and just lost your mind, lose your mind in such situation, but it's okay. See if you can actually make it easy or not. All right. That's it. Solve it further and don't forget to put the bracket. Okay, solve it and get your answer, and you can just answer me in the comment section. What about the next question? See, for now I hope you can solve all these questions, right? Let's try this question also. Now it is about cyclist rides to a cabin 72 kilometer away up the valley and then returns in 9 hours. Okay, so what I can sense from this question, that is going up 72 kilometers, okay, and then coming down. So there is some time taken for going up and time taken to come down, and time taken for the up and down is 9 hours, right? And then return in 9 hours. Are you getting it? Up and down. So it's not like up and down this way, actually, like up and then down, right? I just made it like this so that you can understand what is up and down over here. So going up and then going down. So time taken for up and time taken for down. Yes. All right. Now, of course, you need time for up and time for down and whatever things are given. So time for up will be distance upon speed. 72 is the distance for up and speed is not given. So we have to assume it to be x. Now for the down, of course, the distance will remain the same. But when we actually get down, our speed automatically gets, high, or it increases. So the speed for returning will be x, which was the original one, plus 12 kilometers faster. So x plus 12, and this will equals to 9, right? And what I can sense over here is, of course, you can, yes, please simplify it, okay? Don't start doing it directly. See, this is 9, this is 72. You can sense it, right? Why I'm highlighting this, because 9 8s are 72. You can take 72 common and then can divide and make it even more simple. Okay? Try. I'll just do this part for you, so that if you understand how to frame the equation, you can start solving it directly. Okay? Do this and it will be x plus 12. Yes, and then x upon x square plus 12x is equals to 1 upon 8, or I can just write here 2x plus 12. Okay, just a second. What was written earlier? Let me cross check. I think I wrote something. Oh no, correct. 2x plus 12. Okay, so do the cross, simplify and get your answer. Okay, we have 3 more questions. Why don't you try this as in homework? Yeah, so let me actually check if you can do these questions. Cyclist made a trip of, yes, correct. Exactly like the previous question, you can do it. The distance between the 2 bus station is 240 kilometers. Okay, the speed of the bus increases. We can do it, right? 2 cases with the normal speed and when the speed is 36 kilometer per hour, like 36 plus, right? So earlier it was x and now it will be x plus 36. Distance will remain same. There is a difference in the time which is given to you. Yes. Okay. Sorry. Okay. Let's go to the next question, yeah? All right. So, you read the question. I'm just checking if you can do it or not, whether I have taught you this or not. Yes. So now So when you're going against the wind, what will happen to the speed? Along with the wind, it will increase, just like upstream and downstream. Yeah, along with the stream, it get increased. So here also, along with the speed, along with the wind, your speed will increase, and when you're going against it, the speed is gonna decrease, right? So you can use that. And if the plane was in the air for total, for this, what was the average speed of the plane? Yes. So that's it. I feel you can do it. And of course, there is something actually, yeah, something wrong over here. Let me adjust it, or I can actually make it even big. Okay. All right. Now let's see this question. Okay, let's leave it here, and what we're gonna do is we gonna discuss, I wanted to discuss the case base today itself, but it seems that I made a really long video. So in the next video, I'm gonna discuss the case based and the first 7 or 8 questions which were on the numbers and the digits. Okay, so complete your task and let me know if you are facing any problem or not in the chat box. Bye bye.